We're going to be looking at volumes of cuboids today, just starting off with that. And the first thing we just want to remind ourselves is, what is volume? So what is volume? If we start talking about the volume of something, what do we mean? Okay, well, we mean the amount of space that a 3D shape fills. So it could be any kind of shape, but we can think about the volume as being how many cubes where the side is 1 centimeter long would fill that space. And if the shape we're looking at is just made up of cubes, that's quite easy. We can just count the cubes. But when we've got other kinds of shapes, we need to think about a nice method to enable us to do that. Okay, so like with area, we want to think about these 1 centimeter cubes fitting in. With area, we think about 1 centimeter squares fitting in. So how much space it fills up. And we need to be careful about the units like we did with area. So if the lengths are measured in centimeters, the volumes are measured in cubic centimeters, centimeters with a little 3 on it. If they're measured in millimeters, the volumes are measured in cubic millimeters. If the lengths are measured in meters, volumes are in cubic meters. And if we get something really massive, then we might measure the volume in cubic kilometers. So a cuboid, just starting off with a cuboid. Cuboid is probably the most simple 3D shape we can start with, and it's where all the sides on that shape are rectangles. Okay, if we've got rectangular faces, then we've got a cuboid. So we've got 3 cuboids on the screen there. And if we have all 3 lengths on the cuboid, so the length, the width, so we've got the length there, the width there, the height there. If all 3 of those are the same, then we call it a cube. All right, but a cuboid is one where they can be all different. Well, they could be all the same, but we'll call it a cube if we've got all 3 the same. Right, if we wanted to work out the volume of cuboids, we've got the 3 cuboids from the last slide. To work out the volume of the cuboids, let me bring up a pen. All we need to do is to think about what the length, the width, and the height is. Because I'm trying to count how many of these little centimeter cubes there are in the shape. Well, I can think, on the front face here, I could say, well, there are 5 in a row there, and it's 5 high. So I can work out how many are in the front face by doing 5 times 5, and then it goes 4 back. So to work out the volume, I could just do 5 times 5 times 4. If we do 5 times 5, we're going to get 25, and times 4, it would give us 100. So if they were centimeter cubes, that would be 100 cubic centimeters, that one. All right, this one, we've got the length across the bottom. There is 6. The height of it is 4. And the width of it down the side is 5. So I have to multiply those 3 numbers together for the cuboid. 4 times 5 times 6. Doesn't matter what order you multiply them in. It's all going to work out nicely. 4 times 5 is 20. Times it by 6 is 120. No problem if you need to use a calculator for any of these. Okay, but sometimes there's a way of doing them where you can just quite nicely work out the multiplication by grouping them a certain way. 4 times 5 is quite easy to do. And then our last one here, we've got our length 3. Our width is also 3, but our height is 1, 2, 3, 4, 5, 6. So what we're going to have to do for that one is 3 times 3 times 6. 3 times 3 is 9. 9 times by 6 is 54. So if they were all centimeter cubes, that would be 54 cubic centimeters. So the biggest one, which is what the question said at the start, which one's the biggest one? The biggest one is, the one in the middle. The one in the middle is the biggest one. I'll get my pointer back to where I want it to be. Okay, so there's our biggest one. If we're dealing with something like this, okay, the volumes of all of these cuboids, quick and easy to do, just multiply. That's all we've got to do. Multiply the lengths together, and we're going to get there. Okay, so if we do this one, I'd do 2 times 5 first, because that's easy. And then times by 12. 2 times 5 is 10. Times by 12, that's 120 cubic centimeters. That volume there. We bring up the next one. So this one's going to be a bit trickier because we've got to deal with a decimal, but this is probably where you'd reach for your calculator. So we're going to do it. We're going to go for 8.5 times 6. You could do it longhand if you wanted to. Times by 15. Okay, multiply all that lot together. 8.5 times 6. 8 sixes are 48. And half of it would give us another 3 to add on. So it's 51 times 15. And if we wanted to do that without a calculator, we could do 51 times 10, which is... you got a calculator there. You've got a good brain. All right? So, yeah, you're not wrong, though, because it's 5, 10, and 255, isn't it? Those two added together, because that's 5 lots of 51, half of the 10 lots, 765. So you're spot on. Good, you're keeping up with it. That's good, Ali. All right. 765 cubic centimeters. Go on then, do this one for me. What's that one? $253.125. Okay. And some of these... Sorry, what were you going to say, Ali? Yeah. Cuboids just really easy, isn't it? And it all comes back to just how the shape is, doesn't it? Thinking about how many are in the front face and then multiplying back to say how many rows of it you've got. So it's all quite nice and easy, isn't it? Okay, cool. So let's try this one round then. So this one's a little bit different. We've got 4 cuboids here, and we're told they've all got the same volume. We've got to find the missing lengths. So we've got an A, B, and a C. 3 of them have got missing lengths on them, and we need to find out what they are. So how might you start this, do you think? Yep, that sounds good to me. So let's do that. 3 times 3 times 8, yeah? 9 eighths, 72. Okay, that one's 72. Right. How's that going to help us get A? Yeah, we now know what the volume is. So we know for A, if we were to do 6 times 6 times A, that would have to be 72, wouldn't it? But what's 6 times 6? So 36 times by A is 72. What's A? Yeah. Okay. Not too bad, eh? So we can work out missing lengths. What about if we do part B then? So there we've got 12 times 1.5 times B is our 72 still, isn't it? What's 12 times 1.5? 18. Yeah, you've got it. 4. Yeah. B is 72 divided by 18. Great job. I like the way you described that there, Ali. That's good. That was an 18. I don't know why I made it a 12. Hang on a minute. Get my rubber up. Eraser. There we go. Let's do it properly. And that was 18. And we're absolutely right. 4. Okay, the last one. So we've got 4 times C, haven't we? Yep. 4.5. Okay, this one's not a whole number, but because you're doing it the nice way there, you guys got that? You know that you just need to divide by the 16. 72 divided by the 16. You're done. Yeah? Easy. How easy is that? Yeah, they're all pretty easy, aren't they? Okay, cool. Good job. Right. Have a go. See if you can come back to me. Which one of those is bigger? Which one's got the larger volume? And by how much? Okay, P's bigger. What did you get for P? Yep. Yeah, they're quite close, aren't they? Okay, so you get 1,078. Just 2 difference. So it's just 2 cubic centimeters bigger. Good job. Excellent. Right. Okay. How might you tackle this one? Yep. Okay, so you're thinking, because there's a couple of ways you can do this, isn't there, if you look at it. So are you thinking, Stella, that you just drop, I lost my pointer, that, yeah, you could do that way, couldn't you? Or you could do that way. Is that what you were thinking, first of all, drop it like that? To do the other way? Do you want to do the other way? Okay. It won't make any difference. You should get the same answer. Okay? Because it's just deciding to split it another way. It's entirely up to you which way you do it. So let's go for the way you were just suggesting there then. So you were suggesting do it that way, Ali, yeah? Okay, yeah. Yep. So we've got 5 times 2 times what for the shaded one? Is it 5 again? So we've got 5 here, haven't we? We've got that. We've got, this is 2. Is that the bit we've said is 2? But what's this? 3. Yeah, it's 3, isn't it? It's that bit here, isn't it? Yep. So that's what we're going to do for that bottom one. So it's basically 5 times 6. That's 30, isn't it? Yep. And then we've got the top one to do. What 3 numbers are we multiplying together for the top one? Yep. Like what you're saying there, Stella. 3 across the top, isn't it? Yeah, you were using that there. So you've got that 3, and you've got that 4. They're the ones that come into play there, aren't they? Okay, 4 3s, 12 times by 36. So it's a little bit bigger, that one, isn't it? Overall, 66 cubic centimeters. All right, so even when the shapes aren't exactly cuboids, we can sometimes split them up into cuboids, and we're done. Okay, so that's quite nice. Right. I thought we might play a game. The shootout. Okay, we've done this in class, haven't we? Yeah. So, I don't know. It's going to be tense because, you know. All right, so no talking, no sharing answers. Let's see what we can do. All right. Have you got a calculator each? Just for multiplying 3 numbers together, it should be fine. It should be all right. Okay, here we go then. So this is intense. This is really intense. There's a lot of family, family honour here, isn't there? Right. So everyone, you start on 10 points. So write your points down. If you get the answer correct, you get an extra point. If you get it wrong, you lose a point. Okay? Off we go. There you go. Okay, you can both have a go at it. You don't need to call out because you can both be right. You both got 80. All right. 80 cubic centimeters. Fine. Don't call them out though, okay? Okay. Try and get fast. It is a shootout. That's probably not a bad thing, Stella, to be quick, is it? Okay. Here's your next one. Don't call it out. You both got an answer? 24? 24 cubic meters. Oh, it's tens. Just 1 point. Each time you get it right, you get 1 point. You lose a point if you get it wrong. We're going to be tough now as well. We're going to say you have to have the right units written down. Okay? Not just the number. Yeah, so there you would need cubic meters written down. Okay? We'll let those first 2 go. But now we're going to say just them with a little 3 on it. Yep. like on the screen there. Okay. Yep. Here's your next one. You got an answer? We'll have to go for honesty then. So maybe what you need to do there, Stella, is for you to when we stop, for you to tell what you think the answer is. Okay, and if you say it properly, then that's okay. No, I think you're gonna have to show yours after that just to make sure it says the same thing. All right, 1 cubic centimeter. All right, we're all on 13. We're all on 13. Right. Okay. Next one. You can say it. What we got? 100 cubic centimeters. Okay. Next one coming. You're both on 14. That's all good, isn't it? It means you understand it. If it's coming easy to you, it means you've got it. You got your answers? Yeah. What'd you get? Ooh, cubic meters. Okay. I'm sure you said centimeters first as well, Stella. Right, there you go. Next one. You got it? 70 cubic centimeters. Okay. 140 cubic centimeters. Is it making your booklet messy? All right. Okay. You're doing loads of stuff, have you? By the way, let's say all those lengths are centimeters. Don't worry about the fact one says meters. That's a bit tricky. Take it as all centimeters because if that one was. See, it would be 1,200 centimeters. You would. Absolutely. 72, yeah, exactly. That's what it would do. But we said take it all as centimeters, okay? But you're absolutely right, Ali. It would be 7,200. Good job. Yep. If they're different units, just convert it. All right, here we go. Yeah. 175. Yeah. Good job. 5 5's 25. 725's 175. Yep. 8 cubic meters. Yep. Good job. Ah, this one's telling you what the volume is, but how high is it? You got it?
I like playing Nintendo music on the computer.
Just 3 centimeters because it's a length, isn't it? Yeah, you got the right number. Good job. What about this one? Five centimeters. Good job. So our volume here. 27 cubic millimeters. Yep, good job. How tall is this one? 3 centimeters. Flying. Yep. Right, this one's got a square base. So the length and the width are the same. What are they? Look, 5 centimeters. 5. 5 times 5 times the 2 is 50, isn't it? Yeah, I think we need to do this a bit more, don't we? We've got to get everyone else onto this. Right, there's one for you. It's a cube. Its volume is 64. How tall is it? Okay. So what you're after... Go on. Go on then. 4, yeah. So what you need to think about, the way to do it, the method on this one is, you've got what number when you multiply it by itself gives you, when you multiply it by itself 3 times gives you 64. So what number when you cube it gives you 64? Do the cube root of 64 and it'll tell you the answer. The cube root of 64 is 4. 4 times 4 times 4. 4 times 4, 16. Times 4 again, 64. Yeah, cube root it. All right, this is why they're called cubes and cube rooting, okay? Yeah, why we call those things cubes when we do the power 3 is because it's all to do with cubes. Actual cubes. Okay. Right, there is a tricky one to finish with. So have a think about what happens. You know, it's 3 times these two numbers is going to give you, it's going to give you 150, isn't it? 3 times those two numbers on the bottom are going to give you 150. So what do the two numbers on the bottom have to multiply to give you? So I've got 3 times, let's sketch on here, 3 times 2 numbers, one number that I don't know and another number that I don't know, have to give me 150. What do the 2 numbers multiply to give me then? Don't they give me 50? Yeah, that's right, isn't it? So those 2 would give you 50, absolutely right. But one of them is twice as big as the other. Can you just see what numbers they'd have to be to multiply to give you 50, where one's twice the other? They'll add to give you 50, but you're looking for 2 numbers that need to multiply to give you 50. What possible numbers multiply to give you 50? Give me 2 numbers. I think you've just answered the question there, haven't you? One's twice as big as the other. The answer's 5. Yeah, x was 5. Yeah. Oh, no. When we write things like that next to each other, it means, in algebra, it means multiplied, doesn't it? Yeah. Yeah, so when we write that 2x means 2 times x. So that's twice that value. This value's 5, that value's 10. Multiply all that up by 3, you get your 150. Okay? But that's a tough one. That's a toughie. That's the last one. Okay? Good job, guys. I think that's been useful, isn't it? Bit of fun. Yeah, and there's no more questions to do. That was the lesson. All right? Just to go through that, make sure you were happy in how to work with cuboids. So you're all done. You're welcome, guys. Thanks so much for joining in, and we'll see you next time. See you. Bye.